Alright, this is example 18. Alright, so integral of x squared e to the x. Now before I go over it, I want to give you an idea of what sort of questions come up where you expect to use the by-parts formula. Okay, so notice these integrals are being in the form x times sine x or x times cos x, x times natural log of x, x times e to the x or x squared. There's always been a product of an algebraic term and a non-algebraic term. Okay, and that's what the by-parts method is normally for. Because if you think about the integration by substitution method, you're not going to find a substitution that's going to help you to integrate that. Okay, substitution for those sorts of questions you're doing, but for these sorts of questions, when you've got a product of usually a algebraic term like x or x squared or something like that, and a non-algebraic term like e to the x, natural log x, trigonometric, okay, then you're using by-parts. Okay, and a question is not always going to say integrate this by using the by-parts method. You just got to know that this is the method you've got to use. All right, so that's what you're looking out for. Okay, normally it's two terms and one's algebraic, one's non-algebraic. Okay, now let's integrate this. I'm going to try and squeeze this on. Okay, so here I'm going to write u is equal to. Do you know which one to go for? So why don't you pause the video and try and think about it, and then I'll continue. All right. Did you go for that one? Okay. Why does that work? Maybe think about that and I'll answer it later. So u is that, du dx equals this. dv dx is equal to e to the x, and v, integrate that, is equal to e to the x. Right, I'm starting to do it a little bit more quickly now, okay, because you'll be able to do it as quickly as well. Okay, so let's see what this integral becomes then. So integral is equal to uv, so it's x squared e to the x, subtract integral of v du dx, so that times by that, so 2x e to the x dx. Okay. Can you see what's happened? This is now an easy integral like that. Let's just suppose you try it the other way around. Okay. Let's suppose you try doing u equals e to the x, so du dx is also e to the x, and you tried this way, dv dx is equal to x squared. Can you see why this is going to be harder for us, or the wrong way around? Because you find out what v is, 1/3 x cubed. Now, I'm not going to write the next bit down, but when you write down uv, that's fine. So that times that's not a problem. But then when you subtract the integral of v du dx, you're going to have that times that. So we'd have to integrate 1/3 x cubed e to the x. Whereas before we had x squared. And doing it the right way around, we've got x. Can you see what we're trying to do here? We're trying to diminish the powers of x to make it easier. By turning that x squared term to an x term, it's made the integral easier. If we turn an x squared term into an x cubed term times e to the x, it makes it harder. Okay, so quite often you want the algebraic term to be u. Again, you can make a note of that. Okay. Right, let's go. So we've got x squared e to the x, subtract, got to integrate this now. Well, what do we do about that? Pause the video again, try and think about it. Welcome back. Okay, you need to use by parts again. Okay, this is a question where you've got to use by parts again. Okay, so by parts twice, the same question. Okay, make sure you use a similar approach. Okay, if you want, try it by switching these around, having u as e to the x and dv dx as 2x. But then what you'll find happen is you kind of reverse the process. You get almost back to where you started from. It gets a bit messy. Okay, so when you use by parts twice, be consistent with what you've chosen. So when I say be consistent, I mean let u be the algebraic term again, let dv dx be the exponential term. Okay, right. So because I'm not able to integrate that yet, I'm going to use by parts again. I'm just going to rub that off and do some more work in here. So usually on my board, I'd have all my u dv dx stuff over here, and I'd have it here, here, and my work can go here. But because I don't have that, yeah, woe is me. Okay, all of this going on, and I'm sad about my board. Yeah, go on. Right, so u equals 2x du dx is equal to 2 dv dx is equal to e to the x, and v equals e to the x. Right, let's go. So integral, remember this is part of our final answer, so x squared e to the x. Subtract. Now, when you're subtracting this integral, my advice is put the thing in brackets. I'll explain why once I've done it. So just consider that as an integral on its own, okay? So you've got uv, so that's 2x e to the x, and then subtract integral of v du dx, so that times by that, 2 e to the x dx. Okay, so I just want to reiterate that point about diminishing the powers of x. Notice that on the first application by parts, the x squared term becomes just x, and then the second application by parts, it's effectively x to the power of 0, isn't it? Because it's not there, it's just 2 times e to the x. Okay. Now, let's just work through this. X squared e to the x, then subtract 2x e to the x. This is why I'm suggesting the brackets, because we have to do subtract this. If you miss out the brackets in your efforts to try and get the by parts formula correct, you could easily not realise that that is actually going to be positive down here, okay? And integral of 2 e to the x, of course, is just 2 e to the x, okay? And then plus c, and that's it. Incidentally, I'm sometimes asked, once you've integrated this bit, for example, do you need to put a plus c in? No, you don't, okay? The answer is that the plus c, the constant of integration, only needs to be put in after you've done your final integral. And the reason for that is, suppose you put in a plus c, and then you have another plus c after your final integration, and then you just combine those two constants together and have just one letter. So you only need to put the plus c in right at the end after there's no more integrals to do. Okay, there you go.